Alright, for our project we created GVAL, the GPS Velocity and Acceleration Logger.
Problems: we would need something to record the locational data of a moving target. The data will include the time, longitude, latitude, altitude, speed, and also the acceleration in g-forces. All of this data must be logged onto a SD card. The device would also be lightweight, portable, and power efficient.
Objectives. Our objectives for this project are the following. To create an embedded system that solves the problem of simultaneously logging and displaying the GPS data information at an efficient rate. The system must be able to log the total distance traveled and the maximum speed reached during the travel session. The data must be saved on an SD card of simple format, which can be plotted on a map later to analyze the travel route taken.
If time persists, real-time data should be logged onto an internet web server via Wi-Fi shield, which can be accessed by many different devices in real time. Our initial design comprised of a GPS unit, a display SD card shield connected to the Arduino Duo, with a battery pack and a Wi-Fi shield. If time permits, we'll transmit to a web server.
Problems encountered with the initial design. There are many problems encountered with this project. One miscalculated problem was that we were not able to receive acceleration data solely from the GPS module itself. Therefore, we needed to buy an accelerometer so that g-forces should also be added. It was later mentioned that in order for acceleration to be achieved, a gyroscope was also essential in order to isolate a specific axis in space. There were also many problems displaying the data on the screen, as we were still not familiar with the UTouch library. Spacing the information on the screen nicely, as well as refreshing only the constantly updating data, also proved difficult. The GPS data was also logged very inaccurately, which we solved by casting the data as a float, which can be seen later on. GVAL was very hard to debug when there was no signal available. The first accelerometer was also faulty and had to be replaced.
There were many bug issues that had to be fixed. For instance, the time was displaying correctly but at GMT. The screen was also refreshing too slowly. G-forces were also fluctuating and never accurate. There was trouble calibrating the accelerometer, which may have been due to the power pack.
The final design. The updated final design was the same with some minor tweaks due to the shortage of time. We had our GPS shield connected to the Arduino Duo, which is connected to the TFT shield that logs GPS data onto the SD card. We now added an accelerometer and a bigger battery pack to hold more batteries to sustain long distance traveled. All this were connected onto a breadboard, since many of the Arduino pins are used more than once, such as the essential power pins and ground. To demonstrate the functionality of the GPS, we took the device for a test drive around outer Sydney. On the road, the GVAL displays the speed of the car quite accurately, however, the course heading is fluctuating rapidly. The g-forces on all three axes are visible and show a change for any acceleration or deceleration of the vehicle. The vertical acceleration shows the acceleration due to gravity.
This page shows the longitude, latitude, and altitude. Compared to the actual car's GPS altitude reading, the GVAL reading is very similar. This is the SD card data that was logged by the GVAL in CSV format. This is the initial test run before optimizing the code. As you can see, it is very inaccurate. After increasing the precision in the data, we see a drastic improvement in logging accuracy during the travel.
Overall, we have achieved most of our primary objectives. All that was left to do was to improve the code and optimize the power consumption of the GVAL. We also learned a lot about different libraries that were available to the Arduino Duo, and finally we used a lot of fuel.